In today's session, we are going to solve examples based on open circuit test and short circuit test. So let's begin with the example number 1. So we will start with our green pen. So we'll write whatever the data is given to us. The following are the test results of 10 kVA. So this 10 kVA is the power rating of transformer. So we will write P is equal to 10 kVA, 1100 by 440 volt single phase transformer. That means primary voltage V1 is 1100 volts and secondary voltage V2 is equal to 440 volts. Now the open circuit test. So the data of OC test. So the data of OC test is normal primary voltage and power is 500 watt. So 500 watt is the data from the open circuit test. Then short circuit test from SC test. We can write from the numerical given to us. The power loss calculated in SC test, it's 850 watt and the voltage measured is 40 volt. When the secondary winding is shorted and full load current is flowing. So in short circuit test condition, the full load current is flowing. So that is given to us. Now what we need to find? So data to find. So what data we need to find? The data we need to find is find full load efficiency. So we need to calculate efficiency and regulation at 0.8 power factor. So voltage regulation we need to calculate at 0.8 power factor. So this much of data is given to us, and now we are going to solve example using this data. So let's begin with the solution. So how we can solve this example? So first of all, what do we need to find? Let's write the things that we need to find. First we need to find efficiency. So the equation for efficiency is output divided by output plus losses. But we have two specific losses, iron loss and copper loss. So to calculate the efficiency, we require first of all output. So how to calculate the output? So let's write the equation to calculate the output of the transformer. Output of transformer is equal to kVA cos 5. So we need to calculate the efficiency and voltage regulation. See, find full load efficiency and voltage regulation at 0.8 power factor lagging. So this is key data for us. So the power factor is given to us as 0.8. And the kVA, that means full load rating. Power rating is also given to us. We have written over here. It is the full load power rating. Right. So it's 100 kVA transformer and the power factor is 0.8. So obviously it is 80 kilowatt. So the output of this transformer is now known to us, and that is 80 kilowatt. The data given in OC test, that is 500 watt. This 500 watt is nothing but the iron loss, and this 850 watt is nothing but the copper loss. So we have the iron loss and copper loss amount which is given in the example, but these two amounts are in watts, so we need to convert it in kilowatt and write. So the output we have got 80 kilowatt divided by 80 plus it's a 0.5 kilowatt plus it is 0.85 kilowatt. So now let me calculate this. Uh, 80 plus 0.5 plus 0.85 gives us 81.35. So 80 divided by 81.35 gives us 0.9834. So 0.9834 is the efficiency, and then when we convert this efficiency into the percentage, we need to multiply it by 100. Once we multiply it by 100, we get 98.34%. So this is the first finding from the SCOC test, and it's very good that Saurabh and Parth has calculated it the correctly. That's very good. I appreciate your efforts. Even Kamlesh has also calculated it correctly. So now the efficiency is known to us, and the next thing we need to find is voltage regulation. So ultimately we need to find percentage regulation. So what is the equation of percentage regulation of transformer? The equation for the percentage regulation when the power factor is lagging is I1 R01 cos 5 plus I1 X01 sin phi divided by 0V1, that means no load voltage, multiplied by 100 because we need to calculate this thing in percentage, right? So that's good. Even Kothari, Parth and Kamlesh and Saurabh, you all have calculated the answer correctly. Now what we need to do, we need to place the values, right? So to place the values we require these things. Do we know R01? Is R01 is known to us? No, R01 and X01 is not known to us. So first we need to calculate this. But is the I1 is known to us? No, I1 is also unknown. So we need to calculate the I1, we need to calculate the R01, X01, sin phi, because cos 5 is given to us, that is 0.8. This quantity is known to us, 0.8 lagging power factor. So from this we can calculate sin phi, and V01 is the primary voltage. So the quantities which are marked with yellow marker, that quantities we need to calculate. So what we will do, first of all we will start with calculating I1. So we will place all the values once we are aware with them. So first of all let's start finding I1, and from where we can find I1? I1 is the primary current. So see, SC test is performed at full load. SC test is performed at full load. So secondary is shorted and primary is flowing the full load current. So if we calculate the full load current using this copper loss, it's easy for us, right? So the equation for copper loss WC is I1 square R01, right? So to calculate, this is the equation for copper loss, but this will not gives us the current. To calculate the current we need to use the equation of transformer kVA is equal to V into I. So kVA is power rating of transformer, it is V into I. So if we divide it by 1000 and divide this also by 1000, so that will balance the equation, right? So now let me get the values. kVA rating of the transformer is 10 kVA. So it is 10 in kVA. So what we'll do, we'll multiply it by 1000. So it will become into VA. Voltage is given to us as 1100 and I1 current that we need to find. So from this we can write that I1 is equal to 10,000 divided by 1100. And when it is 10,000 by 1100, it's simple to calculate. Just place the values in calculator. 10,000 divided by 1100, and that's it. It's 9.09, right? So let's go for this. I'm sorry, it's 100 kVA and I have mentioned over here only 10 kVA. So that's a mistake. It's 100 kVA. So over here there will be one more 0, and in this point will be shifted on right hand side. So we'll get not 9.09, but we will get 90.9 ampere of current. So that's good. Kamlesh, good. Parth, good. But I did that small mistake in writing the data, so the answer is slightly a different one. But you can correct it right now and you can carry on the same thing with me. Okay, so good. You have updated it. Good, Kamlesh. So now as we are ready with I1, now we can calculate the remaining thing. Now we know the I1. Now we'll go for the R01, right? So we are now finding R01, and to calculate R01 we are going to use the equation of copper loss. WC is equal to I square R, and that is I1 square R01. So as we want to find R01, we'll rearrange the equation like this. So this WO or WC is 850 watt, right? It's 850 watt divided by I is 90.9 square. So let us calculate. 90.9 into 90 point, sorry, 0.9, 8262.81. So 850 divided by 8262.81 gives us 0.1028. So it's 28, so we'll take it as 3, so 0.103. So 0.103 ohm will be the value of resistance. So now the resistance is known to us, R01 is known to us, and now we'll go for the X01. See, do you remember this equation? Z is equal to under root R square plus X square. So this is known to us. If we calculate this using this equation, we can calculate the X. And to calculate the Z, it's very easy. Why? Because we can use this equation. Z01 is equal to, Z is ultimately the impedance. So impedance is volt by current. So VSC, right? Short circuit voltage divided by the current at short circuit time. And what is short circuit voltage? The short circuit voltage is given to us is 40 volt. So we'll use VSC 40 divided by IT is 90.9. So 40 divided by 90.9 gives us 0.44. So this equal to 0.44 ohm. So now the Z is known to us. Very good, Saurabh. Good work. So now the Z is known to us, that is 0.44 ohm. And if we place the value of Z over here, we can get x01 is equal to under root Z01 square minus R01 square. So Z01 is 0.44 square minus R01 is 0.103 square. So 0.44 into 0.44 gives us 0.193. So this is 0.193 minus 0.103 into 0.103, it's 0.0106. 0.0106. So 0.193 minus 0.0106 gives us 0.1824, and under root of this is 0.427. So now the x01 is 0.427 ohm. So now this quantity is known to us, x0, r0, right? So we know I1, we know R01, we know X01, right? Now we need to calculate the sine 01. It is very simple, that you need to remember this. When cos 5 is equal to 0.8, sine 5 is equal to 0.6. And let me show you the process to calculate this. If you want to calculate this thing, that how when the cos 5 is 0.8, sine 5 is 0.6, then you can follow this procedure. Phi is equal to cos inverse of 0.8, and using this you will get phi angle, right? So sine of this angle will give you the value of sine, and that will be equal to 0.6. So this is how you can calculate this thing. Good, Saurabh. Good work. What about other participants? Limited participants are responding today. Is it anything wrong with you all? What happened? So now we'll write the equation for regulation again. Percentage regulation. The equation for that is I1 R01 cos 5 plus I1 X01 sin 5 divided by 0V1. I1 is 90.9 multiplied by R01 is 0.103 multiplied by cos 5 is 0.8 plus I1 is 90.9 multiplied by X01 is 0.427 multiplied by 0.6 divided by 1100. This 1100 is the primary voltage, this one. So now our task is to calculate this thing. So let's solve this thing in a small steps. First we'll calculate 90.9 multiplied by 0.103 multiplied by 0.8, and that gives us 7.49. So we'll take it as 7.5. 7.5 plus 90.9 multiplied by 0.427 multiplied by 0.6 gives us 23.288. So we'll take it as 23.29. So 23.29 divided by 1100, and that gives us plus 7.5 divided by 1100, that is 0.02798. So we'll take it as 0.027 or 28, 0.028. So it's 0.028. It is percentage regulation, so over here we need to write multiplied by 100. Over here also it's multiplied by 100, and over here it's also multiplied by 100. So finally we get the percentage regulation is equal to 2.8%. So this is our another finding. So this is how you can calculate the percentage regulation and the efficiency of the example.